Is the volumetric flow rate changing for this problem? Remember, A goes to B plus C, so we know that epsilon is not 0. And we were told that, you know, it's a flow reactor. Pressure's not changing, so yeah, volumetric flow rate is changing. So we can't just put V0 here. But stoichiometry tells us that we can write where again, 2 means the second reactor. Do I have to worry about the pressure term, P over P naught? No, I was told it's negligible. It doesn't matter that it's the second reactor or the first reactor. I was told to assume it's negligible. I mean, I'm going to take that to mean negligible throughout the whole system. Yeah. All right, so this is the initial concentration of A at the inlet of the second reactor. And of course, it's isothermal, so that's why the temperature difference is, you know, T over T naught doesn't show up. And CB, if I still want to write it in terms of CA, which I do, CaO2, and now what do I put here? Is there an inlet? This is theta B, which is equal to what? 0. I was told that pure A, no, wait. No, I know, I'm just, he doesn't have it. Yeah, no, we don't have to do any of that yet. I'm just trying to figure out why he doesn't have theta B here. Okay, and then you have plus, one sec, plus x, and then the denominator is going to be the same. Somebody asking a question? All right. All right, so the third step, we combine, right? So you get FAO Okay, so some things simplify. For now, I gotta look at that closer. Like I said, I'm a little worried that I grabbed, like I said, sometimes he'll change the problem solutions, but just very slightly. So he might have said that all B was removed in the purifier, which would explain why theta B is not in this solution. But he doesn't put the problems in his solution. So I should have worked these out ahead of time, but the ones that I looked at looked correct. Okay.
Why is CA not squared?
Because it's in CA. It's not. Where did I put that it was? Sorry, that's a typo. Yeah, no.
I think you just accidentally.
Oh, sorry. Yeah, it's.
You accidentally put your top instead of.
Yeah. I just made it a superscript instead of a subscript. It's 2 because it's the inlet to the second unit. Okay, so this simplifies out to just K times CaO to 1 minus X over 1 . And so the initial flow rate here, remember that all we had to do was solve the differential equation. And if we're defining our parameters as a reminder, this is the flow rate of A into the second PBR, the concentration of A in the inlet of the second PBR. This is the conversion with respect to the inlet to the second PBR. And this is the weight of the catalyst in the second PBR. This is epsilon for the second PBR. Yeah.
Okay, so is epsilon 2 different than epsilon, and is the x equal to x2?
What is epsilon equal to? Not 2 times delta. That's what the 2 means. It just means that the molar fraction of A that you use in the inlet for this problem needs to be based on the inlet to PBR2. So yeah, I mean, it's kind of sloppy, but all the x's should be x2. All the epsilon should be epsilon 2. That kind
All
of
of
thing.
them should be epsilon 2?
For this problem, for this part of the problem, yes.
Okay.
But again, if you define it well, you're fine, right? You could have left out the 2 from all of this and just said, all of this is based on the inlet to their second reactor.
But if the feed is pure A, wouldn't both epsilons be the same?
The feed is not pure A. That's the feed to the first unit. I took off theta B because the purifier can remove all of B, which I think is how this was set up.
Yeah.
But I've still got C.
Oh.
Don't forget that we had 2 products. The purifier doesn't remove C. You know, it either removes 50% or 100% of B, and at some point during this problem it changed. Okay, part B. Part B says evaluate or it actually says compute all parameters that appear in the equation obtained in part A. Notice that it doesn't say to solve this differential equation. It just says solve for all of these parameters. So what parameters do we have? FA naught. What else? The inlet concentration. X2, that's, to do that I have to solve the differential. He's not asking for that. He wants to know the parameters. K is a parameter, epsilon 2 is a parameter. That's it, I think. Okay, so K is given, so that's easy enough. That was 0.8, I believe. No, 0.2. Second? Yeah. Okay, what's epsilon 2 equal to?
Y not 2.
And what's delta? So epsilon 2 is just equal to y a naught 2. So that's another parameter that we need to solve. So what's FA naught 2? If I go back to my diagram,